Hey everyone, we're going to take a look at number 6 from section 4.2. In this problem, they ask us to find all critical points of the function, and the function is x, in this case, times the natural log of 10x. Your function will be similar to this. Just made a quick note, this is not including the information, but you should realize that the domain of this function is not all real numbers, right? The logarithmic functions here, log base e, ln, right? Its input must be greater than 0. So 10x must be greater than 0, meaning x has to be a positive quantity. So the domain will only be positive values. Okay, and parenthetically, they say to use symbolic notation here and fractions where needed. So in my language, this is give the exact value. Okay, give the exact value. Give your answer in the form of a comma separated list. So that's only if you have more than one critical point, you would list them with a comma separating each one. And if the function doesn't have any critical point, you would just enter DNE for your answer there. So using the product rule, we're going to find the derivative of this function, right? I've got a product, x times the natural log of 10x. So I take the derivative of x, which is 1, times the natural log of 10x, plus x times the derivative of natural log of 10x. That's going to be chain rule, right? So you've got log of ln of u is the outer function. 10x is the inner function. So outer function derivative is 1 over u. So u being 10x gives you 1 over 10x times the derivative of what's inside, which is 10. But that simplifies down to just 1 over x. Just a side note, so that's by the chain rule. This natural log of 10x by the property of logarithms, remember the log of a times b is the log of a plus the log of b. So I can write the log of 10x as the log of 10 plus the log of x. And then I can take the derivative. Log of 10 is just a constant, and derivative of that is 0. Derivative of natural log of x is 1 over x. So either way you look at it, you should get 1 over x as the derivative of the natural log of 10x. So over here, I've got 1 times the natural log of 10x plus x times 1 over x. What's x times 1 over x? That's going to be 1. So there's my derivative. This is never undefined on its domain. Again, the domain here is still, x being greater than 0. So we do need to find out when this function, for what value of x, the output to this derivative, rather, is 0. And so does everyone see? I hope that that will be true when the natural log of 10x is -1, right? -1 plus 1 being 0. So in this form now, to solve for x, we need to write in exponential form. Remember, logarithms are exponents. So this is the natural log, which is log base e of 10x is -1. So -1 is the exponent on the base e, which gives you 10x, right? So 10x is e to the -1 power. So I can solve for x dividing by 10. Of course, e to the -1 is 1 over e. So I guess either of these forms should be fine and achieve. I think this is the one that they're showing as they want, but I would, for me, probably write it in this form. But this is the one critical point for this function. There's no other. So this would be the only one you would enter in for the answer here. Okay. Hope that this is helpful. And as always, let me know if you still have questions.